All right, let's go ahead and get started. Last week, I had a chance to actually talk to the Hawks representatives, some of the head folks of Hawks and stuff, about one of our biggest issues, which is, we labeled these quizzes, quiz 1, 2, 3, 4, 5, so forth and so on, and you guys trying to figure out which quiz goes with what, because with the homework sets, you had 1.3A, 1.3B, 2.1A, 2.1B, stuff like that with the A and Bs. We don't typically do that with these pre-section stuff. The pre-sections quizzes are to give you an introduction to the concept. I work a few problems that are just like your homework sets or your quiz, the little pre-section quiz that you have to take. And then you're supposed to sit there and do those pre-section quizzes and trying to basically work at the same kind of pattern here. But I wrote this thing up just to make sure you guys are on the same page in terms of which quiz numbers go with what. So as we started, and here's how you really keep up with this stuff. Quiz 1 is section 1.3, quiz 2 is section 1.4, quiz 3 was section 1.5, quiz 4 is section 2.1, quiz 5 is section 2.2, quiz 6 is going to be on what we're doing today, finishing up today, is section 2.3. Quiz 7 is on section 2.5 because we skip over section 2.4. And then quiz 8 is on section 2.6. And the reason why I stop at section 2.6 is very simply, at the end of chapter 2, we have our first big homework set and test. So my goal here is I'm working on it, so it'll be out very soon, probably before the end of the week, probably by Wednesday if I do my work right. You'll have your homework set, which will mimic exactly what the in-class test is supposed to be. There's also going to be a web test that you're going to take through the Hawk system, so it works kind of like all the homework problems have done. So the homework problems are setting you up with your little web test, which is going to be part of your test grade. And the homework set that I'm creating, and I'm going to go over in class, or on Fridays or something other, we're going to, those homework sets are going to well represent, how do I put this distinctly, pretty darn close to what you can anticipate what the test is going to look like, especially on the word problems and the wording about certain problems. And you get a problem and knowing exactly what to do. I'm trying to signal you guys on your homework set. So before every test, I'm going to give you guys this homework set, kind of something for you guys to have in your hand to practice, so you're not so surprised when you actually, test day, and I hand you a test and it's on all the material we've been doing. That homework set will really set you up very well for that. Yes?
Is our test going to be on 1.3 through 2.6?
Yes. Yes.
Quiz 7 and quiz 8 are due today?
What's that now?
Quiz 7 and quiz 8 are due today?
Quiz 7 and quiz 8 are due today? Don't think so. Let's find out. Okay? Let's, if I went over here and moved this thing over, quiz 7 and quiz 8, let's see here. That's due within a week, so that's actually probably by the end of the week is quiz 7 and quiz 8 are due. Quiz 5 and 6, let's see here, is, well, like I said, we've started section 2. Where we started section 2.3 last time. Remember, these are supposed to be pre-section quizzes. They're supposed to be done just before we start this material and stuff like that. But how many folks did quiz 6 and did great on it? Okay, how many people haven't even looked at quiz 6? Oh, that's bad. All right, it's always next semester. All right, so, but how many people, do you need an extension on quiz 6? No? Well, is it due today? I don't know. I better check the due date here. All right, so quiz 6. See, I've already taken quiz 6, so I don't know. See, once you take the quiz, it throws it out of the system and stuff like that, and I have to go through the gradebook thing. When will you be taking your test? That's another good question. Well, let's see here. All right, let's talk about strategy. Now, I'm doing 2.3 and 2.5 today. Okay, that's my goal. And so after 2.3 and 2.5, and then I only got one more section to go. We're talking about that's Wednesday. So we're talking about next week, probably around Wednesday of next week, which means Monday I'm looking for the homework set. But tell you what, I will quote all this good stuff for you guys on Wednesday. Let's see how fast we get through this material. All right, so To remind you of what we were doing last time, in section 2.3, we were working on quadratics. And I want to remind you that there are 3 different ways we can solve quadratic equations. The first one is what we really did last time, and that is the classic factoring. You set a quadratic equal to 0, like for example, x squared minus 9x equals 0. You factor it, x times x minus sign. You set each factor equal to 0, and you solve. You also have x squared minus 3x minus 10 equals 0. This was a quadratic that factored, so that's x minus 5 times x plus 2, and you factored it. You set each factor equal to 0, and you solve. And that's pretty much what we did through all the problems we did last time. Now, the next one that we're picking up with is this. Solve by using the square root property. We're setting you up for something right. I've got x plus 3 squared minus 16 equals 0. The ultimate goal on any kind of an equation is to solve for x, is to get x by himself. So on this particular style of problem, when I want to get x by himself, I'm going to get the term that has an x in it by himself. So my first move here is to add 16 to both sides. Get the x plus 3 squared equals 16, which means I'm getting my x by himself. So, but this is a, quote, perfect square. This is x plus 3 quantity squared. What gets rid of squares? Square root. Square roots kill off squares, cube roots kill off cubes, so forth and so on. But so I'm going to now take the square root of both sides. The square root of x plus 3 squared would be equal to the square root of 16. But here's the deal. Anytime you're manipulating an equation and you have to introduce a square root into the problem, you don't know which one I want because you got 2 options when it comes to square roots. What are those 2 options? Plus or minus. So anytime you actually input into the problem a square root, don't forget, you got to do plus or minus. Because when it comes to quadratics, how many traditional answers do you expect? 2. Being an x squared kind of a problem, you expect to have 2 answers. Now, let's clean this up. The square and the square root cancel. That leaves you x plus 3 equals plus or minus. What's the square root of 16? 4. And with that plus or minus, that's going to give you your 2 equations. You get the 2 equations. X plus 3 equals negative 4, and x plus 3 equals positive 4. Set each factor. The x plus 3 equals to the positive 4, the x plus 3 equals negative 4. Now solve for x. I'm going to subtract 3 from both sides, and that gives me x equals minus 4 minus 3 is a minus 7. And then I got x plus 3 equals 4. I'm going to subtract 3 from both sides, and that gives me x equals 4 minus 3 is 1. And there are my 2 equations, 2 solutions to my equation. Does that make sense? So what about this guy here? 4x squared minus 20 equals 0. You could, if you wanted to, factor out the 4 and do the factoring method of difference of squares, but the problem with that is you're going to get some nasty numbers on this. Well, with the square root thing, you're going to get nasty numbers too, but when you can get the x by himself because you don't have a middle term, that's exactly what you should do. Get the x by himself. So on this problem, I would add 20 to both sides. That gives me 4x squared equals 20. And then remember, you're trying to get the x by himself, so how do I get the x squared by himself? Divide by 4. So I'm going to divide by 4 on both sides, and that gives me x squared equals 5. But now, to solve for x, what do I got to do to get rid of that square? And when I introduce the square root, what do I got to do? Plus or minus. So that cancels, and x is equal to, well, 5 is prime, so it doesn't factor, so you can't clean it up. So you get plus or minus the square root of 5. Or, just to let you know, there are 2 answers. X equals positive square root of 5, and x equals negative the square root of 5. Those are my solutions. Does that make sense? All right. And the purpose for this is to do these kind of problems. And these words tend to scare a lot of students, but don't worry, we'll walk you through the steps on this. Solve by completing the square. Now, I'll be the first to admit to you, when do I solve a quadratic equation by completing the square? when somebody puts a gun to my head and says, solve by completing the square. This is not the technique I use or like, because we can either factor it or we like everybody's been in here, I had this stuff before, the quadratic formula. The only time I actually use solve by completing square is when it's in the directions. They're pointing the gun to your head and saying, hey, do it this way because we want you to see if you can actually work these problems out. So to do this, there's steps involved. So let me give you the steps involved in solve by completing the square. All right? So here, let's look at this example. I'll go through the steps with the example. I've got x squared plus 10x plus 20 equals 0. The directions say solve by completing the square. Step 1, get the x terms on one side and move the constant to the other. So S1, step 1, move constant to other side of x terms. So to move it to the other side, I'm going to subtract 20 from both sides. This is going to give me x squared plus 10x equals, a little space there, equals negative 20. Get the x's on one side, the constant on the other. Okay? Step 2, factor coefficient in front of x squared out of the x terms. Factor the coefficient in front of x squared out of the x terms. What is the coefficient in front of this x squared understood to be in this problem? 1. So there's nothing to factor out. But if it was a 2 or a 5 or something like that, then you want to factor it out of all the x terms because you want to make sure the coefficient in front of the x squared is a 1. Okay? This one's already good. Okay? Already good. And let me put this, and divide both sides. All right, so let me factor the coefficient in front of the x squared out of the x's and divide it on both sides. You want to make sure the coefficient in front of the x squared is a 1. But my guy's already a 1. Then you got step number 3. Step number 3 is your big step right here. So I'll put a big asterisk by this one. Take 1/2 times what I call the b term. The b term is the coefficient in front of the x. Take 1/2 the b term and square, okay, and add to both sides. This is what completes the square. Now I use this word b term because it's coming from the old quadratic formula. The coefficient in front of the x term was the b term. So in this problem right here, x squared plus 10x equals negative 20, what's the b term? 10. The coefficient in front of the x is 10. So you're supposed to take 1/2 times 10 and square it. What's 1/2 of 10? 5. What's 5 squared? 25. And this is your magic number that's going to complete the square. Add this number to both sides. So that's going to give me x squared plus 10x plus 25 is equal to negative 20 plus 25. Because remember, what I do to one side of an equation, I do to the other. Makes it a perfectly legal math move. Okay, step 4. Factor the x terms. Factor the x terms. And what I mean by factor, because you have actually taken 1/2 the b term and squared it and add this special number to both sides, it will factor what we call perfectly. Let me show you. X squared plus 10x plus 25. How does that sucker factor? X, what times what is 25 that adds it to be 10? 5 and 5. And what are my signs with everybody being plus? Plus and plus. It's always the same thing. It's perfect square. So what you're going to get here is x plus 5 quantity squared equals, you might as well go ahead and clean up the other side. What's negative 20 plus 25? 5. Step number 5, Now, take, what gets rid of a square? Square root of both sides. And remember, plus or minus, and solve for x. Take the square root of both sides, don't forget plus or minus with the square root on the constant, and solve for x. Because how many answers are you expecting with this stuff? 2 answers. So to kill off that square, I'm going to take the square root of both sides, but when I take the square root of a number, I got to do that plus or minus. The square and the square root cancel gives me x plus 5 is equal to plus or minus the square root of 5. And you can write it as 2 equations if you want to, or you can write it like this. Solve for x. What would you do to solve for x? Subtract 5 from both sides. That gives you x is equal to negative 5 plus or minus the square root of 5. How many answers are there? 2. X equals negative 5 plus the square root of 5, and x equals negative 5 minus the square root of 5. We occasionally write it in short notation with the plus minus thing, but on your Hawk system, they're going to want it in the 2 separate answers. Does that make sense? But look at these steps. I do the same steps every time. It just takes some practice. So, step 1, make sure the coefficient, move the coefficient, the constant coefficient to the other side and get the x terms by himself. 2, make sure the coefficient in front of the x squared term is a 1. If it's not, factor it out and divide it on the other side. Step 3, you take half the b term and square it and add that number to both sides. Step 4, factor the x terms. And then step 5, take the square root of both sides and solve for x. So let's do this step again. Here we go. I got x squared minus 7x, I should screw that up. X squared minus 2x equals 7. All right? Step 1, it's a quadratic. Get the x terms on one side and move the constant to the other. Well, that's nice. I think they already did that one for me. I got x squared minus 2x equals 7. You with me? Step 2, what is the coefficient in front of this x squared term? 1. If it was some other number, factor it out and divide it to the other side. Does that make sense? But this is a 1 again. Don't worry, we got the next problem. Okay, here that one. Then the next step is this. Take 1/2 what I call the b term and square it and add this number to both sides. What is the b term in this problem? Very good. Sign goes with it. Excellent. -2. So you're going to take 1/2 of that -2, the coefficient in front of the x, multiply 1/2 times -2 and square it. What's half of -2? What's -1 squared? 1. That's the magic number that's going to complete the square. And you add this number to both sides. So this is going to give you x squared minus 2x, leave a little space, equals 7. And I'm going to add 1 to both sides. What I do to one side of an equation, I do to the other, makes it a perfectly legal math move. Now, step 4 is you need to factor the x squared terms. How do I go about doing that? Okay? How does x squared minus 2x plus 1, how does it factor? It factors how? X, what times what is 1? 1 and 1, and what are my signs to get the middle term to be a minus? Minus, minus. It's always the same. Equals, now 7 plus 1 is 8. So this gives me x minus 1 squared equals 8. Now, what gets rid of the square and how we're going to solve for x? What kills off that square? Square root. So I'm going to take the square root of both sides. Square root of x minus 1 squared equals the square root of 8. And when I introduce the square root of 8, I got to do plus or minus. That's what's going to give me my 2 answers. But now, let's review back to some of the other stuff you've been doing. The square and the square root cancel. That leaves you with x minus 1 equals plus or minus. What about this square root of 8? 8 is what? Break it down, because it's not prime. It's 2 times 2 times 2, right? But you remember about cleaning up square roots. With a square root, for every pair, you'll get to pull one out. For every pair, you pull one out. So this will be x minus 1 equals plus or minus 2 square roots of 2 is what the square root of 8 is equal to. That make it look good. And now what am I going to do to solve for x? Get x by himself. What would you do? Add 1 to both sides. This cancels. You get x equals a positive 1 plus or minus 2 square root of 2. And there's your answer. Question for you, though. How many answers are up here? 2. What are the 2 answers up here?
1 plus 2, 1 square root of 2, and 1 minus 2.
Very good. X equals 1 plus 2 square root of 2, and x equals 1 minus 2 square root of 2. Perfect. Does that make sense? Now, of course, you chunk this on the calculator and go for the decimal answer, but a lot of the times they want what they call the exact answer. This is the exact answer, this 1 plus and minus 2 square roots of 2 stuff. All right, let's see if we can do this hard one. All right, so let me blow it up so everybody can see this thing. I've got 3x squared minus 5x minus 10 equals 0. Step 1. Now again, the directions. Solve by completing the square. Again, the only reason why I'm doing this is because they told me to. Because next section is going to be the quadratic formula, which gives us the answer a lot quicker. Solve by completing the square. 3x squared minus 5x minus 10. Step 1. What's the first thing I got to do? No, first thing I got to do is get the x's by themselves. Move the constant term to the other side. Does that make sense? That's step 1. Your focus is on the x's. So on this problem, I would add 10 to both sides. That gives me 3x squared minus 5x equals 10. Now, what is the next move? You got to make sure the coefficient in front of the x squared is a 1. So to do that, I said factor it out, but you factor it out and then move it to the other side. But just as easy to do that, to get the coefficient in front of the x squared as 1, is pretty much divide each term by, in this case, the 3, because you got to make sure the coefficient in front of the x squared is a 1. And that's right, we're going to get crappy fractions with this one. So what do I get when I do that? X squared minus 5/3 x equals 10/3. To make sure the coefficient in front of the x squared is a 1, I said factor it out and move it to the other side. That's the same thing as divide each term by the coefficient in front of the x squared to make sure the coefficient in front of the x squared is a 1. Does that make sense? Now, complete the square. How do I complete the square? Here's the big move. You take 1/2 the b term and you're going to square it. This is the actual number that completes the square. What is the b term in this problem? Very good. Sign goes with it. Negative 5/3. So, order of operations, work inside the parentheses first. What is 1/2 times negative 5/3? Well, 1 times negative 5 is negative 5, and 2 times 3 is 6. Then you got to square it. What is negative 5 quantity squared? 25. Negative times negative is positive. 6 squared is 36. 25/36. That is the number that completes the square. 1/2 the b term squared. So this is the number I'm going to add to both sides of my equation. And hopefully you guys can see my awesome red ink pen here. That becomes plus, believe it or not, that's red. 25 over 36 plus 25 over 36. Okay? So this turns into this. This is a perfect quadratic. X squared minus 5/3 x plus 25 over 36 equals, now over here on the left, excuse me, on the right, put my calculator on the left, I'm going to take 10/3 and add it to that 25 divided by 36. And what do I get? And again, I want a fraction out of this guy. I'm going to get 145 over 36. All I did was just add my fractions together. Does that make sense? Now, the next step is after you have the b term, square it, and add that number to both sides. Now factor the quadratic part. How does x squared minus 5/3 x plus 25 over 36 factors? Well, here's the deal. It factors perfectly, so I know it's going to be the same thing. X squared's got to be x and x. What about 25 over 36? What times what is 25 over 36? What times what is 25? 5. What times what is 36? 6. So it's 5, 6 on both sides. Now, what's my sign have to be? They have to be the same sign because it's plus, but which sign should I take? The negative, because the middle term is negative. Catch a pattern. Equals 145 over 36. This makes it, as awful as it is, x minus 5, 6 squared equals 145 over 36. Now, the last step is, what kills off that square so I can solve for the x? Square root of both sides, and don't forget to do the plus minus. So I'm going to take the square root of both sides and plus or minus on my number. That gives me x minus 5, 6 is equal to plus or minus the square root of 145 over 36. But you can clean that up a little bit. I'm not sure about 145, but it's a square root and it's a fraction, so I can do square root of top over square root of bottom, and I can take the square root of 36. What's the square root of 36? So this is x minus 5, 6 is equal to plus or minus the square root of 145 over 6, because the square root of 36 is 6. And then the last thing you want to do is what? Get x by himself, add 5, 6 to both sides. They already have their common denominator, so I'm going to get this. X is equal to positive 5, 6 plus or minus the square root of 145 over 6. And just because I want to make sure you guys understand with these quadratics, there are two answers. The answers are x is equal to 5, 6 plus the square root of 145 over 6, and x equals 5, 6 minus the square root of 145 over 6. Awful square rooty problems there, but that is your solution. Does that make sense? Yeah. Please.
So if we had like a number like 145,
Yeah.
would you want us to,
Break it down? Yeah. Let's see what 145 is. 145, I believe I can divide that by 5. And it's 29. 5 times 29. What do you guys know about 29? And how does 29 factor? It's prime, so it doesn't factor, right? And because 145 is pretty much 5, which is prime, times 29, which is prime. There are no perfect squares like that square root of 8 problem we did. There's nothing to pull out. If there was, I would have done so. Okay. Question?
Why would you prefer the quadratic formula over the square?
Okay. Good question. Why would I prefer the quadratic formula over complete the square? Well, hold that thought for a second and turn to the next page. And let me do a couple of problems, and then you tell me which one you prefer. And again, it's up to you, because honestly, if you actually do a complete the square on a quadratic formula problem, now granted, it's going to take you lots of time. And I believe the reason why I do, it's a time issue. I like to get the answers and get them quickly. With all these 5 steps, it just eats up time because I have to do each step. But with the quadratic formula, you just literally plug it into the formula and it gives you the answer a lot quicker. That's the reason why. But again, you'll learn that as you do more and more problems. Okay? Take a look at this problem here. Now, first off, quadratic formula. Now, again, this is something that we expect everybody that's even come close to graduating high school to memorize. When you have the quadratic formula, ax squared plus bx plus c equals 0. X, the solution, is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, sign goes with this stuff. All you got to do is set the quadratic equal to 0 and figure out a, the coefficient in front of x squared, b, the coefficient in front of x, c, the constant. And just plug it into this formula. And then it becomes arithmetic in terms of cleaning up the formula. So, again, because the quadratic formulas work hard problems and they work easy problems too. Let's take a look at this one. I've got x squared plus 2x plus 1 equals 0. Directions say solve by using the quadratic formula. Fine. Quadratic formula. I've already got my quadratic set equal to 0, step 1 there. What's a, what's b, and what's c? You read it right off. What's the coefficient in front of the x squared? Understood, even though you don't see it there. 1. What is the coefficient in front of the b? What is the coefficient in front of the x? Called b. 2, sign goes with it, plus 2. What's the coefficient for the constant term, c? Positive 1. So x is going to be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Plug it in. X is equal to b, negative, it's going to be negative b, negative 2 plus or minus the square root of b, 2 squared minus 4 times a times c all over 2 times a. Now, look how I plugged it into this formula. I did an over amount of parentheses on this thing and plugging a, b, and c into the formula. Why? Careless errors. You know, negative times a negative is a positive. You lose one sign, you've got the problem all wrong. So I'm literally using parentheses on plugging this in, and now I'm going to clean it up. This is negative 2 plus or minus the square root of 2 squared is 4 minus 4 times 1 is 4 all over 2 times 1 is 2. So x is equal to negative 2 plus or minus the square root of, what's 4 minus 4? 0 over 2. And here comes one of these unusual spots. What is the square root of 0? Because everybody went away. 0. And when I plus or minus 0, adding or subtracting 0 doesn't matter. I'm left with negative 2 over 2, which is, what's negative 2 divided by 2? Negative 1. X equals negative 1. And you'll notice, wait a minute, I only got one answer. Yeah, but this one answer is a double answer. You get it twice. Let me show you why. Now, they asked me to do it this way, and because what was under the square root was a 0, you can sometimes get one answer. But the reason for that is this. If you go back and look at the original problem, x squared plus 2x plus 1 equals 0, personally, without them telling me to use the quadratic formula, I would have factored this guy. How does x squared plus 2x plus 1 factor? X plus 1 times x plus 1 equals 0. You set each factor equal to 0. X plus 1 equals 0. X plus 1 equals 0. You get x equals negative 1. X equals negative 1. You actually get it twice, but since it's the same number, we just write it one time. X equals negative 1. Does that make sense? All right, so let's work on one that's a little nastier. 5x squared plus 2x minus 2 equals 0. Now, they've already done it for me, but I want to emphasize to you guys, when you're using the quadratic formula, you've got to set the quadratic equal to your favorite number, which is 0 before you start this mess. This one is already set equal to 0. X squared by 5x squared plus 2x minus 2. Now, once you got it equal to 0, quadratic formula, read it right off. What's A, what's B, and what's C? A is what? 5, the coefficient in front of the x squared. What's B? 2. No, B is 2, the coefficient in front of the x. But what is C in this problem? Sign goes with it. Negative 2. So this one's positive, so I wrote positive 2 there. This one's positive, that's positive 5. But it's plus C, but you see that minus, the sign goes with the number, negative 2. So I write down my formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. That's right. You're expected to memorize this thing. Plug it in. But watch how I plug it in. Because right here is where students will make careless errors and lose all the points off this problem. It's negative b, which is 2, plus or minus the square root of b, which is 2 squared, minus 4 times a, which is 5, times c, which is negative 2, all over 2 times a, which is 5. I am very methodical in using these parentheses and plugging these numbers in for their respective A, B, and C spots. Now, just be careful where the careless error comes in at, and I've crunched the numbers. Negative 2, that's negative 2, plus or minus the square root of 2 squared, which is 4, minus 4 times 5 is 20, and 20 times 2 is, that's a negative 2, excuse me, so it's 4 times 5 is 20, and 20 times a negative 2 is negative 40. I'll go back and clean them up. That's a minus, and that all that multiplied together is negative. That negative times a negative is going to make it positive. All over 5 times 2 times 5, which is 10. What is 4 minus negative 4. Minus negative makes it plus, so this is negative 2 plus or minus the square root of 44 all over 10. Does that make sense? But we're not happy at an answer looking like that. Why? Because underneath this radical, we can clean them up. What exactly is 44? So this is negative 2 plus or minus the square root of, what's exactly 44? Break it down. Well, it's 4 times 11, right? But what's 4? 2 times 2 times 11. That's your prime factorization here. I factored it down because I see there's a perfect square in here. What's the square root of 2 times 2? But for every pair, what do you get to do to clean up a radical? Pull one out. So you get x is equal to negative 2 plus or minus 2 square roots of 11 over 10. Now, very important, watch what I do. I want to clean this thing up. There's a couple of different ways to clean it up. But here's what I want you to do. We're into, this whole chapter is about cleaning up, factoring, and simplifying. What do you have in common in the two terms in your numerator? I have a 2 in common. I'm going to factor out the 2 because strict multiplication division is where things cancel. I can factor out the 2. That leaves me with a negative 1 plus or minus the square root of 11 all over 10. And with the strict multiplication division, I can clean that up. 2 divides into 10 how many times? 5 times. So I get the answer negative 1 plus or minus the square root of 11 all over 5. And there's my solution. How many answers are up here? 2 answers. Those 2 answers are x equals negative 1 plus the square root of 11 over 5, and x equals negative 1 minus the square root of 11 over 5. We just do this fancy plus minus because that's where your solutions are coming from. Does that make sense? All I did was I got it down to this one. I cleaned up the 2 times 2. That's 4. Square root of 4 is 2. For every pair, I pull one out. I pulled out a 2, and it's gone once I pull it out. So it's 11, but I have a 2 in common, so I could factor out the 2, and so I can clean up the 2 divided by 10. 2 divides into 10 5 times, so I've reduced my fraction on it. Does that make sense? Bless you. Let's take a look at the next one. 4x squared minus 3x equals negative 1. Directions say solve. Using the quadratic formula. What's your first move on this problem? Set it equal to 0. Because right now, if you try to use the quadratic formula, you'll mess it up because you'll get A, B, your C will actually be the wrong sign. You got to set it equal to 0 first. So the first move I'm going to do is add 1 to both sides. That's going to give me 4x squared minus 3x plus 1 equal to 0. Now, once you got it equal to 0, what's A? 4. What's B? Negative 3. And what's C? 1. Does that make sense? Now, what is the quadratic formula? X equals negative B plus or minus the square root of, what is it? B squared minus 4AC all over 2A. Plug in our numbers into it. X is equal to negative B, which is negative 3, plus or minus the square root of B, which is negative 3 quantity squared, minus 4 times A, which is 4 times C, which is 1, all over 2 times A, which is 4. Notice how methodical I was about plugging it into the formula. So now, clean it up. What's a negative 3? Positive 3 plus or minus the square root of negative 3 quantity squared. Is it 9 or negative 9? Well, what does my calculator do this for me? What's this? Negative 3 squared. It says it's negative 9. Very good. That's a common mistake that most students make. Because calculator is going to do order of operations. You do exponents before you do signs. So it would square to the 3 and then just make it negative. That's why the answer is negative 9. But when you actually do it the right way, -3 with the parentheses, quantity squared, that's gonna give you what it really is, +9. Just watch the careless errors. So it's 9 minus 4 times 4 is 16 times 1 is 16, all over 8. This is equal to 3 plus or minus the square root of 9 minus 16. What's 9 minus 16? -7, all over 8. So x is equal to what? No solution. Y is the answer, does not exist, or no solution.
There's negative.
Yep, pay attention. There, when I cleaned it up, there's a negative underneath the radical. You can't take the square root or an even root of a negative number. That's why I'm done. No solution to this problem. The answer does not exist. Does that make sense? So watch the arithmetic with this, because all people die on this stuff. It's careless errors. All right? Now, there's a special part of your quadratic formula, which I'm sure you've heard of before, and that is with the quadratic formula, just to remind you, I have ax squared plus bx plus c equal to 0. The answer is -b plus or minus the square root of b squared minus 4ac all over 2a. But because we have issues with negative things underneath the radical, we focus on the type of solutions. And we focus on something called the discriminant. The discriminant, we'll label him big D for discriminant, is the b squared minus 4ac part, which is the part that's underneath the radical. So, now, the discriminant just tells you what type of solutions there are. So when a problem asks you what type of solutions or how many solutions you're going to get, all you got to do, they didn't ask you what is the solutions, because you got to pay attention to the question. The question is how many solutions they're going to get. That's a discriminant question. So you take the quadratic, ax squared plus bx plus c, set it equals 0, and you focus on what's inside the radical, the b squared minus 4ac. And if that b squared minus 4ac is greater than 0, you're going to get 2 real solutions. When the b squared minus 4ac is equal to 0, you saw an example of that plus or minus the square root of 0, we end up getting just one answer, one real solution with that. And when the b squared minus 4ac is less than 0, it's negative, that means you got a negative underneath the radical, the square root, which means there are no real solutions. The answer is going to be does not exist, no real solutions. Does that make sense? So, again, it's not the question, it's not the answer, it's the question. What are they asking for in this problem? This question, number 12. How many solutions does 5x squared plus x plus 2 have? Equals 0. Have? How many solutions? Well, a is equal to 5. B is equal to what? What's the coefficient from the x? Understood, even though you don't see it. 1. What's c equal to? 2. So plug it into the discriminant. B squared minus 4ac. D is equal to B, 1 squared minus 4 times A, which is 5, times C, which is 2. This is equal to 1 minus 20 times 2 is 40. I got a negative 39. My discriminant is negative 39. Less than 0. What does that tell me? No real solutions. Does that make sense? Questions? All right. What about this one? X squared plus x minus 6. How many solutions does this thing have? Equal to 0. Well, A here would be 1. B would be equal to 1. C would be what? Good. Negative 6. So the discriminant, which is b squared minus 4ac, which would be 1 squared minus 4 times a, which is 1 times c, which is negative 6. That's 1. And negative 4 times 1 times negative 6 is plus 24. That's equal to 25. D equals 25, which is greater than 0. That tells me there are 2 real solutions. And think there's a typo on this one I want to fix. I want to make that one a 6. My fault there. I know yours may have already got it fixed. My notes may be old, so tell me when my notes don't match up with your notes. I think, was it last week you guys told me there was a problem?
Up to date, it's
Don't match up to date at all?
No, you skipped all the quadratic examples on this one.
Really?
There was only one example.
Wow. I gotta fix that, because that's a problem with the redesign program altogether. So I will make sure that I reboot up all these solutions and stuff. So write them down in your notes, because they're awesome examples here. So I actually have more examples than you guys have? Oh, well, great, okay. So x squared minus 6x plus 9. What's A equal to? 1. What's B equal to? -6. And what's C equal to? 9. Okay? So, my discriminant's going to be b squared minus 4ac. So my discriminant's going to be b, which is -6 squared minus 4 times 1 times 9. -620 squared, what's that? 36. Minus 4 times 1 times 9. 4 times 9 is 36. And 36 minus 36 is 0, which means my discriminant is 0, which means 1 real solution. And you can go factor and figure out x equals, was it positive 3 or something like that when you solve it. Does that make sense? All right. Try this one. Is the application on your homework on this? No, okay, great. All right, I got to work on rebooting the notes, because my notes, I printed them off the system, but I don't know. We're having Moodle issues, and I bet you anything, I uploaded it, and it went back to the old system, and I imposed a new set over the old set, and just kept the old set. I don't know. We've been having Moodle issues all semester long, and it's getting worse these days. All right, let's try this one. Application. A rectangular parking lot has a length 3 feet greater than its width. The area of the parking lot's got to be 180 feet squared. Find the length and the width. All right. So when in doubt, draw a picture. We have the width and we have the length. But it says this: in a rectangular parking lot, the length that is 3 feet greater than the width. The length, how do I write an equation out of that? The length is means equals 3 feet greater. I'm going to add to the width. So I add 3 to the width, and that equals length. Does that make sense? All right. Keep going. The area, but if you draw this thing out, it's a rectangle. What's the area of a rectangle? Length times width, but they tell me that is 180 feet squared. But to get my equation, length is equal to 3 plus w. So I'm going to substitute. So area is equal to length, which is 3 plus w, times w equals 180. And this is where I'm going to get my equation from. I'm going to distribute 3w plus w squared equals 180. And what did my problem just turn into? Quadratic. So we got w squareds instead of x squareds. It's the same thing. Does that make sense? But rewriting this guy, this is w squared plus 3w equals 180. Being a quadratic, what do I want to do with this guy before I try to start looking for some solutions? Outstanding. Set it equal to 0. So subtract 180 from both sides. That gives me w squared plus 3w minus 180 equals 0. Now, you've got 3 options on solving this thing. Your choice. You can either, 1, factor it, 2, complete the square, or 3, quadratic formula. I got a question for you. Does anybody in here really want to complete the square on this thing? Never. Unless someone puts a gun to your head. Good. So we really, because again, not that you can't, it's just that it takes too much time. So personally, I would either factor it or quadratic formula. Well, let's see here. If I can do it quickly, I'll factor it. What times what's 180 that differs by 3? Well, I can factor 180. 180 divided by what? 20? That's 9, but the difference to 29 is not 3. So I gotta go bigger. 180 divided by 30 maybe? 30 is 6. Nope, it's getting bigger. How about 15? Bingo. 15 times 12 is 180. 180 is 15 times 12. So this will be W. 15 times 12 is 180. And because it's a minus, one's a plus, one's a minus. And so I want the difference to be 3, which it is. And since the middle term is plus, I want the bigger number to be plus and the smaller number to be minus. And so I set each factor equal to 0, and I solve. W equals negative 15, and W equals 12. Does that make sense? Here's the deal. Let's say, man, I was working this problem and I just did not catch the factors of 15 and 12. You know what you could have done? Quadratic formula, and it would give you the same answers. Plugged it into that formula and put it on your calculator and crunched them out. It would give you negative 15 and positive 12. But now, step 27 on any kind of word problem. Always go back and answer the questions. What's the question? Find the length and the width. Well, the width is equal to, and what's the length going to be equal to? What did I get for the width? I solved for it. What did I get? Negative 15 and positive 12. Well, we're talking about measuring stuff. So these are real answers. Can you measure negative 15? No. That's an extraneous solution because you can't have a negative distance is my point. Does that make sense? So my answer is 12. And don't forget your units. 12 what? What is this stuff measured in terms of distances? Feet. So the width should be 12 feet. And the length, which is width plus 3, that's my formula that we came up with, would be equal to 12 plus 3, which is equal to 15. So length equals 15 feet. Does that make sense? Great example. All right. Section 2.5. Section 2.5 is on the first part, well, it's on rational expressions and equations. What's a rational expression? That is an expression that has fractions in it, with the variable either in the numerator or denominator, or both for that matter. So then, 2 divided by 5 minus x. This is a rational expression where you have what we call, quote, a polynomial. That also includes constants in the numerator and denominator. But when it comes to rational expressions, the one problem you got is when you got division, you can't divide by what number? 0. You cannot divide by 0. That's going to give you guys, quote, issues. So we have what we call restricted domains. We got to figure out where's our problem going to be at. So if you look at this problem here, 2 divided by x minus 5. What number can x not be equal to? What number can I not plug in for x here? 5. X cannot be 5. Does that make sense? Because I plug in 5, that makes me divide by 0. What does that make the domain of the function then? Well, x cannot be 5. What numbers can x be? Because that's the definition of domain. The x values I can plug into a function. I can't plug in 5. What can I plug in? Negative 14, 100, 202, negative 1, 3, 6, negative 5 is fine. What numbers is in the domain? Negative infinity to 5 union 5 to infinity. It's all the numbers except 5. Does that make sense? Okay. So, try this one. What number can x not be equal to? I've got x divided by x squared minus 4. Well, 2 is one of them, but there's another one out there as well. Right, and how I would find it would be, I would take my denominator, x squared minus 4. I would set it equal to 0 and try to figure out where my problems are going to be at. This would be x plus 2 times x minus 2 equals 0. Okay? So I set each factor equal to 0. X plus 2 equals 0. And x minus 2 equals 0. And that gives me the answers. X is equal to negative 2 and x is equal to positive 2. So x cannot be equal to positive 2, and x cannot be equal to negative 2. Those are my problem points. What does that make the domain of my function? Negative infinity up to, you always use the number line. So imagine the number line. Here's my number line. Here's negative infinity. But at negative 2, I've got to omit. Positive 2, I've got to omit. So I want all the numbers between except for these two guys. So what is my domain? Negative infinity to negative 2. Union negative 2 to positive 2, the stuff in the middle. Union 2 to infinity. It's all of them except positive or negative 2. Does that make sense? What about the third one? X divided by x squared plus 3. What can x not be equal to? Well, no, don't care about the numerator. The numerator doesn't matter. It's just the denominator. I can't divide by 0. I don't care what the denominator is in there. I can't divide by 0. So all you got to do is take the denominator, x squared plus 3, set it equal to 0, and try to figure out the x is going to make that bottom, the denominator, equal to 0. Well, how would you solve this? X squared plus 3 equals 0. Very good. See last section. Subtract 3 from both sides. That's going to give you x squared equals negative 3. Now what you going to do? Take square root of both sides. When you take square root of a number, don't forget plus or minus. So square root of x squared is just x equals plus or minus the square root of negative 3. And what do you happen to notice? There's a negative underneath the radical. So there is no solution. Does not exist. Does that make sense? So, what number can x not be equal to? What is a symbol with a 0 with a line through it? Well, no solution or empty set. That actually stands for the empty set, which means there are no answers. Does that make sense? Okay. So, there are no places where the denominator is equal to 0 at. So, what's the domain of my function then? If we don't have a problem with anybody making me divide by 0, all real numbers. How do you write all real numbers in interval notation? Negative infinity to positive infinity. Open parentheses on that. Does that make sense? All right. Before I go on to the next step, I did want to mention this, that Andrew has made up a seating chart for us. And at the beginning and at the end of class, he's going to be taking the seating chart and rolling it out and making sure that people are still sitting in their seats. We decided to go with the seating chart based upon, I think last time and time before, he's been collecting data. You guys have been sitting in the same seats over and over and over again. So Andrew is going to be taking the seating chart and for obviously Monday and Wednesday classes. And I also want to again remind you about Friday classes. We have class in here Friday at 12:30 if you can make it to go over some of the Hawk system stuff, go over any kind of problems you got. And for those people that are consistent on coming in on Fridays, I promise you there's extra bonus points to be had in this class for going the extra effort and coming in on Fridays and trying to do these homework sets and asking any questions you guys happen to have and stuff. So there's points connected, not just because we like doing it. We're actually giving out free points for those few folks that have been here on Friday. But the majority of you guys haven't come on a Friday. That means to me you must be understanding this stuff completely. Yeah, I don't think so. So I think you guys need to be showing up on Friday and getting some extra help. And also, you guys know where my office is? That's what I thought. It's in Fretwell, 335A, if you happen to have any questions, and come by my office hours. There's also Fretwell 315's open, and once they finish the Math Resource Center, well, there's going to be a place right across the hall from the math department you can get some help in. But as I told you guys, they told us it'd take about 2 weeks for them to get their place ready. It's been 4 weeks, and they're still nowhere close to getting that thing ready. Welcome to state government, and slow as molasses on getting stuff because they've already been paid. Why not worry about it? So there you go. So they'll get it done whenever they get it done, but we will have the Math Resource Center due soon. So I just want to remind you there, we take roll at the beginning of class, of course. We also take roll in the class. So if you've not been sitting in your seat the whole time, you get absolutely no credit for being here. All right. Also, I sent out this past weekend, I was ordered to send out the early alert system. So some of you guys got a little message from me about your grades is not as good as they need to be. That means that you're behind or you haven't actually done some of the homework problems or the pre-section quizzes. And for what, on the numbers I got right now is based on the computer stuff. So if you haven't been doing that consistently, it's been showing up on the grade book and stuff. So I also extended some things over the weekend and stuff, so make sure you guys still have a chance, because if you are in trouble, you got plenty of time to pull it up right now. But don't start procrastinating and fall behind now. You'll never catch up in a semester. And we don't. I don't know where people get this idea that we go back and reopen a bunch of homeworks at the end of the semester and computer stuff at the end of the semester to give you a final chance to do it. That's not college. We don't do that. I mean, you got to get it done the time that we're doing it here in class. I mean, I don't mind giving you an extension right here, but you're surely not going to get an extension in December. Okay, so don't bank on that one. Get your homework done. All right. Simplifying rational expressions. First off, here's the deal. A rational expression is a polynomial divided by a polynomial. The only way you can simplify, aka clean this guy up, is it's a fraction. The only way you can clean up fractions, it's got to be strict multiplication division. That's when things cancel, strict multiplication division. And that's what factoring does for you. Factoring turns this stuff into multiplication division. So if I wanted to simplify x squared plus 2x divided by x squared plus 4x plus 4, I would first factor the numerator. How would you factor x squared plus 2x? I'd take out an x. That'll be x times x plus 2. How would you factor x squared plus 4x plus 4? I do the anti-full factoring thing here. X squared is xx. What times what is 4? That adds up to be 4. 2 and 2, and your signs are plus and plus. And remember, factoring turns things into strict multiplication division. That's when you can clean this stuff up. What cancels? X plus 2 and an x plus 2 cancel, leaving me with what's left. X over x plus 2. That is simplifying. Does that make sense? Did I lose you anywhere? All right, go back. Try the next one. Okay. Hopefully you have the same problems I do. I got x squared minus 1 over x squared plus 3x plus 2. All right, how does this thing, first off, to clean it up, you got to factor it. How does x squared minus 1 factor? X plus 1 times x minus 1 is the famous difference of squares. How about x squared plus 3x plus 2? How does that factor? Outstanding. X plus 2 times x plus 1. X squared is x and x. 2 is going to be 2 and 1 because it's plus plus. They're going to add up to be the middle term measure. 2x and 1x makes the 3x. What cancels? X plus 1's cancel. You're left with what? X minus 1 over x plus 2. Now, multiplying rational expressions is the same thing. You've got a fraction times a fraction. But the only way you can clean up a fraction times a fraction and something's going to cancel is to factor it. And so strict multiplication division, the factors cancel. But you got to factor it. So I've got x plus 5 divided by x minus 2 times x squared minus 4 over x squared plus x plus 6. All right? Well, how is this thing going to factor? Well, I got x plus 5 over x minus 2. There's nothing factoring on that. Times, but I do have something factoring in my numerator. What is that? What is x squared minus 4? How does that factor? Difference of squares. X plus 2 times x minus 2. Over, how does x squared plus x plus 6 factor? I agree. 6 factors into 2 times 3, but the signs are plus. What are the factors of 6 that's going to add up to be 1? Well, that would be a minus, and then but to be able to do negatives, you've got to have a negative back here. You see what I'm getting at? It's not going to factor. I know what you're thinking. You're thinking x squared plus x plus 6. Shouldn't that factor to x plus 3 times x minus 2? Well, not only if that was a minus, because if I fold this out, this is x squared plus 3x minus 2x, but then it's going to be a minus 6. We got a plus 6. This thing doesn't factor at all. When it doesn't factor, just leave it alone. X squared plus x plus 6. But there is something that does cancel here. X minus 2's cancel. That leaves me with, and I leave your answer in factored form is always best. X plus 5 times x plus 2 divided by x squared plus x plus 6. And that's what it's going to be. But be careful, they like to throw these problems at you that don't quite factor to make sure you're double checking yourself that it really does factor and stuff. Now, got a question for you. So when you got a fraction, you want to simplify it, you want to factor it so your numerators, denominators cancel. When you're multiplying, you want to factor so the factors can cancel. But what about when I'm dividing? What's the trick, the mathematical operation, when you have a fraction divided by another fraction? What do? You invert multiply. Multiply by the reciprocal for the fancy folks. Flip and multiply for the rest of us. So, you see this problem right here. All right. Here's my problem. I got x squared plus 6x plus 9 divided by x squared minus 1 divided by x plus 3 divided by x minus 1. The first thing I'm going to do before I flip and multiply is factor it. How does x squared plus 6x plus 9 factor? X plus 3 times x plus 3. How does x squared minus 1 factor? X plus 1 times x minus 1 times x plus 3 divided by x minus 1. All I did was factor. This one, x squared minus 1 is a difference of squares. X plus 1 times x minus 1. X squared plus 6x plus 9 factors in x plus 3 times x plus 3. Now, oops, and that's a divide mark. Sorry about that. Divide mark there. Divided. I haven't done anything yet. But now, once I factor it, now what am I going to do? Invert multiply. But which one are we going to flip? We're going to flip or do the reciprocal of the first term or the second term? Second one, the one we're dividing by. Don't flip. The first one stays alone. So this will be x plus 3 times x plus 3 divided by x plus 1 times x plus 1. But then it turns into times and I invert multiply. X minus 1 over x plus 3. Now what cancels? Oh, then that's a minus 1 there. I missed it. X minus 1 there. What cancels? X minus 1's cancel. What else cancels? X plus 3 cancels. What am I left with? X plus 3 over x plus 1. But there's one extra thing they're going to make you do with this mess. What are they going to make you do with this? They want you to state the domain restrictions. And what I mean by domain restrictions, the restrictions are what x cannot be equal to. What can x not be equal to? Domain restrictions here. Well, to figure out the domain restrictions, go back to the problem before you started canceling. Here's my problem before I started canceling, and look at your denominators. I've got x plus 1 on the bottom, and I got an x minus 1 on the bottom, and I got an x plus 3 on the bottom. You understand? All of these terms are in the denominator before we canceled. So even before you canceled, you got to make sure that the x is, because this is a cleaned up answer, but remember, you canceled out a problem, but the problem is still there at that point. You have to, so just before you cancel, figure out what's there. So when I set all these guys equal to 0, what's x going to be equal to? Negative 1, what else?
1.
Positive 1 and negative 3. So my restrictions are x cannot be negative 1, x cannot be 1, and x cannot be negative 3. Also, go back up here to before you flipped it. There was another denominator, which was x minus 1, and that can't be equal to 0, but we've already covered him. But be careful. Sometimes they'll throw something new in you before, and this was the original problem. And this is a denominator, and denominators, don't care where they're at, cannot be equal to 0. So these are my restrictions. These are the points. And remember, this is the final answer after I clean it up, but before you clean it up, you figure out what your restrictions are. Because you can't divide by 0. All right? How do you add or subtract fractions? Question, yes ma'am.
For that last problem, why did you use the x plus 3 that wasn't one of the original, it wasn't original?
Yeah, well, okay, so good question. All right, it wasn't original, but when I divide by a fraction, what do? invert and multiply, multiply by reciprocal, flip and multiply, right? And when I flipped it, that x plus 3 did show up in the denominator.
So it's anything that was in the
Any,
denominator?
anytime it was or it will be in the denominator, you have to be careful and make those restrictions. So even though it wasn't in the denominator with the divide, when you inverted and multiplied, it did show up in the denominator, and once it's in the denominator, I gotta make it a restriction. Does that make sense? Okay. All right, so question for you, goes back to the third grade. How do you add or subtract fractions? What do you gotta have? Common denominator. So even with these rational expressions, not quite third grade material, these things are kind of nasty, we're still going to be doing the same thing. We got to get a common denominator and get both fractions that we're adding or subtracting in terms of that common denominator so we can put them together. Now, when it comes to these rational expressions, a lot of the times the common denominator is just the two denominators slapped together because they have nothing in common. But if they do have something in common, you do want the least common denominator. So, on this problem here, I got 5 divided by x minus 2 plus x divided by x minus 1. I want you to add these two fractions together. But to be able to add those two fractions together, you've got to come up with a common denominator. What's your common denominator going to be with x minus 2 and x plus 1? X minus 2 times x minus 1, right? You just put the two denominators together. But remember this, you are manipulating fractions. Whatever you do to the denominator, you got to do to the numerator. What did you do to this x minus 2 to come up with the x minus 2 times x minus 1? You multiplied by x minus 1. So I got to do it to the top. So that becomes 5 times x minus 1. What did you do to the x minus 1 to come up with the common denominator x minus 1 times x minus 2? Multiply by x minus 2. So that's x times x minus 2. Then once you get your common denominator, you write your answer as one big common denominator, which is x minus 2 times x minus 1, and then all your action goes into the numerator. 5 times x minus 1 plus x times x minus 2. And then you want to clean up the numerator. How are you going to clean up this numerator? I'm going to distribute the 5. That's going to give me 5x minus 5 plus, I'm going to distribute the x. That gives me x squared minus 2x all over x minus 2 times x minus 1. Now I want to clean it up. And what did that numerator turn into when you distribute all the terms? X squared. So it means it's a quadratic. Typically we like to write this in decreasing order. So this is x squared. Combine like terms. What is 5x minus 2x? Plus 3x minus 5. Well, 5, it doesn't factor because 5 has only got a factor of 1 and 5. And that difference is not going to be 3. So this is the best I can do. Divided by your common factor denominator, x minus 2 times x minus 1. And there's my solution. Does that make sense? All right, 30 seconds. One more. Let's see if we can do this one. 4 divided by x squared minus 4 minus 3 divided by x squared minus x minus 2. What's the first thing you're going to do? Factor it. This will be 4 over x plus 2 times x minus 2 minus 3 over, how does x squared minus x minus 2 factor? X minus 2 times x plus 1. My question to you is this. What is your common denominator going to be? The common denominator, when you're comparing denominators, is basically the entire denominator has to be there, but it's the smallest denominator. I don't want to just slap them both together. I want to make sure that all the terms are there within this denominator. So it's the least common denominator. So it's the biggest denominator, the biggest small thing that I can come up with. So I've got to have an x plus 2 and an x minus 2 in my common denominator. There's the x minus 2 already taken care of, but to get a common denominator, I also need a x plus 1. So that becomes my common denominator because within that big common denominator, you should see both denominators here. So I've got x plus 1 times x plus 2 times x minus 2. What did I do to this denominator to come up with the least common denominator here? I multiplied by x plus 1. So what I do to the bottom, I got to do to the top. That's 4 times x plus 1. Minus, there's a 3 there. What did I do to the x minus 2, x plus 1 common denominator? X plus 1, x minus 2 to get the common denominator? I multiply by x plus 2. So it's 3 times x plus 2. So I write it as one big common denominator, x plus 1 times x plus 2 times x minus 2. And all my action goes in my numerator. 4 times x plus 1 minus 3 times x plus 2. How do you clean up this numerator? I'm going to distribute. Keep it one big common denominator. Distribute. This is 4x plus 4 minus 3x minus 6. What's your signs? And the last thing you do is combine my terms. What is 4x minus 3x? X. What is 4 minus 6? Minus 2 over x plus 1 times x plus 2 times x minus 2. Are you done, or do you see it cleaning up one more time? What cleans up? Right, you've got the same numerator denominator factors canceled out. X minus 2 is canceled. And when everybody cancels, what are you left with? 1 over x plus 1 times x plus 2. There you go. Study this stuff, and we'll talk about the rest of the thing before the test on Wednesday. Great class not to miss. See you guys then.